Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to be a introductory video here on the topics of correlation, regression, and the what's called the correlation coefficient. So let's start with correlation. Now for this discussion I've generated 5 graphs here of y against x, and presumably these are relationships between some variable x, and x being on the horizontal axis is what's called the independent variable, and then some variable y being on the y-axis. Whatever y is, it's the dependent variable. And as we look at these graphs, this one right here just seems like it was just random generated noise, but you'll notice here this graph's a little different. As we go to the right, these points in general are kind of decreasing, and over here these points, as we go to the right, the y values on average are getting bigger. You'll notice over here these seem to be a little bit more tightly related here, and same thing here in these examples. So correlation is a word describing how one variable, or whether one variable is related to another. In this example right here, there seems to be no correlation between y and x. In this example, actually these two examples, it appears that y and x are at least moderately correlated. Here there seems to be strong correlation between y and x. Right? So that's what correlation is. Correlation is a description, I guess, if you will, of how strongly one variable appears to be related to another. Right? No correlation, moderate correlation, strong correlation. Okay, regression. Regression is a statistical method of coming up with a function relating to variables. So for example, in this example, we may decide to attach a linear function to these, and if we draw it, it might look something like this. Right? And then over here it might look something like this, and over here something like this. Regression is a statistical method used to find functions that seem to describe data. I'll make another video a little bit more on how regression functions are calculated. What a correlation coefficient, or what I like to call just an R value, is a numerical value between -1 and 1 that describes how good your function describes the data. Okay, I guess that would be a good way to put it. This stuff here is not correlated, so any function that we try to attach to this, we're going to have an R value basically of 0. I'll just put approximately 0. Now, R values of 1 and -1 mean you have very, very, very good correlation, or almost perfect correlation. The plus and minuses. In this example right here, if I were to draw a linear function through this, these are very strongly linearly related with a positive slope. So this example, you would have an R value approximately equal to 1. You know, maybe I'll just put 0.95 or something for this example. Not perfectly 1, because there's some deviation here and here and here, but this thing definitely has a strong linear relationship with positive slope. Over here, if I find some sort of function that describes this data, again, we have very strong correlation here. It has negative slopes, so this example would have an R value close to -1. I'll put approximately -0.95, I guess. I'm just making up the 9.5. It might be 9, it might be 8.7 or 9.3 or something, but the point is that this is very strong correlation. This has negative slope, so that means an R value very close to -1. This value right here, these are just slightly correlated. If I find some sort of a function here, the R value for this, it might be something like 0.6, 0.5 or something. I'm just making up numbers here. It's not 0. 0 means no correlation at all. There is some correlation here, so this might have an R value of maybe 0.6 or something, and again, I'm just kind of making that value up. Over here, this function, this data, if we attach a linear function to it, it might look something like this. This would have some sort of, median range, if you will, R value, maybe something like approximately -0.6. The minus sign is just because of the negative slope relationship. All right, so R values basically are numerical values that describe how well your function fits the data, right? An R value of 0 means it doesn't fit it at all. Okay, whatever function we attach to this, it's not going to work. An R value of 1 or -1 means perfect fits. Now, we usually don't even really care about the minus signs. Usually what we need, we just use R values to measure how well our function works. So it's very common to not even worry about the minus signs and just look at r squared. Right? If I look at the value r squared, what that does is it makes all the values positive, and then r squared equals 1 means perfect correlation. R squared close to 1, I'll put approximately 1 means very, very good correlation. R squared close to 0 means no correlation. So again, this is just meant to be an introductory video about these concepts. I think I'll just end that there and make another one for the next part. Have a great day.